You're out hiking in the wilderness, and the fog blows in. How do you know which direction to go? If you're smart, you'll have a device used by travelers for centuries, a compass. Compasses always point north. The reason they do this is because the compass is magnetized, and Earth is also magnetized. The compass lines up with Earth's magnetic field, which is oriented in a north-south direction. But think about this. What causes Earth's magnetism and why is it important? This bar magnet causes iron filings to line up along lines of force. Earth is also a magnet, but Earth's magnetic field is generated by electric currents deep within the planet and extends high above the surface. Earth's magnetic field is not completely understood, but magnetic fields always surround electric currents, so we know there must be currents deep inside Earth. In the center of the planet, the liquid outer core is made mostly of iron and nickel, two highly magnetic elements. Heat keeps the molten material constantly moving, and it's this motion that generates the electric currents, which in turn creates the magnetic field. Earth's magnetic field is directed downward in the northern hemisphere and upward in the southern hemisphere. At the north and south magnetic poles, the magnetic fields are vertical. The true north and south poles are the points where Earth rotates on its axis. The magnetic poles, where the compass needle points, are offset from the true poles. Because of the uneven movement of the molten outer core, the magnetic poles wander somewhat and require regular updating. They have moved noticeably in the last 200 years, sometimes by as much as 40 kilometers in a single year. This map shows the changes in the location of the magnetic North Pole since 1904. The magnetic field reaches far out into space, creating what is called the magnetosphere. The magnetosphere is constantly bombarded by solar wind, streams of gases and particles that blow outwards from the sun. If this solar wind reached Earth, it would be very destructive to all living things. But instead, Earth's magnetic field shields the planet and deflects the solar wind back out into space, much like the way the bow of a boat deflects water. Occasionally, strong gusts of solar wind are able to penetrate the magnetosphere, causing radio and television static, power blackouts, navigation problems for ships and airplanes with magnetic compasses, and damage to satellites and spacecraft. Earth is surrounded by the Van Allen radiation belts, two regions of highly charged particles trapped in Earth's magnetic field. Particles from the solar wind become caught in the radiation belts and spiral back and forth along the magnetic field lines. They come into the atmosphere near the north and south magnetic poles, where they collide with molecules of gas in the atmosphere, creating auroras, or what we call the northern and southern lights. Scientists don't know why, but every several 100,000 years or so, the magnetic poles reverse their polarity. The North Pole becomes the South Pole, and the South Pole becomes the North Pole. Evidence for this change in polarity shows up in many rocks. When molten rock cools, it takes on a magnetic signature matching Earth's magnetic field at that time. Being able to determine the magnetic polarity in ancient rocks has helped in plotting the movement of continents, the dates of volcanic eruptions, and it has played an important role in confirming theories about changes on Earth's surface. Much still to be learned about the Earth's magnetism, but we know it plays an important role in providing an environment that makes life possible on our planet.